Afternoon, everybody. Welcome to the Headwaters Science Center live stream. Before we get started, I'm Carl, and Headwaters Science Center, we're open 7 days a week. So Monday through Saturday, that'll be 9:30 to 5, and on Sunday, that'll be 1 to 5. So today we're going to talk about kind of a personal favorite of mine, and that is Therizinosaurs. Behind me, I've drawn the dinosaur for which the group gets its name, Therizinosaurus. With a human for scale. Figured I'd start getting into that habit with these animals. So Therizinosaurs touch on a lot of interesting concepts about evolution, biology, and the way we look at dinosaurs. So they were not a very long-lasting group. They only evolved around 96 million years ago and went extinct around 66 million years ago with the rest of the non-avian dinosaurs. So they were pretty much just late Cretaceous. The smallest one would have been around 9 to 13 feet long, only about 1,000 pounds, which saying only about 1,000 pounds sounds a little bit weird with modern standards of animals. But for the time it wasn't, as the largest Therizinosaur could be around 33 feet long and 11,000 pounds, which is really heavy. And they were pretty much we only have skeletal evidence for them in Asia and North America, which at certain times of the Cretaceous, in that span of 96 to 63 million years ago, had land bridges or other means that animals could travel between. But there is some track evidence for Europe as well. So, first thing about them is they are Saurischian dinosaurs, and they are actually theropods. So in the same family of dinosaurs as a lot of those big carnivorous dinosaurs you're used to seeing, like raptors, tyrannosaurs, spinosaurs. So they are theropoda. But they are not really all that similar when we get into their anatomy. So they are also in the order Maniraptora, which is a really weird order of dinosaurs. A lot of them feathered, a lot of them just very odd anatomies. And then they are Therizinosauridae. It's a very hard word to pronounce. I never took Latin. So what makes these dinosaurs weird for theropods is a mix of features. So first thing is their pelvis was wider and the pubis bone was rotated the opposite way as most theropods had. The other thing is that you'll notice they have this big round body with a big gut. They don't look all that fast. And they weren't. These animals had relatively slow speeds. They're not really built for running. They had these large arms, though, which had these massive claws, which initially the claw was at first thought to be the rim of a turtle shell. Then they realized, okay, it's actually a claw, but what's going to use a claw this size, and what for? For a long time it was thought as a predator that used that claw to slash at its prey, which wound up not being correct. And they are one of those dinosaurs that they are feathered, and we know what type of feathers they had due to some good impressions. They had very ostrich-like, emu-like feathers, where they're very, almost just like shaggy kind of fur-like feathers, which would have been great for insulation. The other thing about them, compared to most carnivorous dinosaurs, they have this very small head and a very long neck. And even the front of their jaw was sort of like a beak almost. They had very, peg-like teeth. So you might be noticing these don't sound like the traits of a carnivore, and they aren't. Therizinosaurs, most of them are thought to be herbivorous. Some of them were omnivores earlier on. These were plant eaters. And it is very odd for a theropod dinosaur to do that. And it's probably why they look so different. The closest thing I could compare them to today would be like kind of like a panda or a black bear. And a big question is, why be so different than other theropods? Why evolve herbivory as a strategy? And one of the hypotheses around that is to avoid competition with the other theropods in its ecosystem. Therizinosaurs shared their habitats with stuff like dromaeosaurs, tyrannosaurs, carcharodontosaurs. Very large, effective carnivores. And it would have been very hard to compete with them. And in nature, oftentimes, when it's hard to compete with other animals in your similar niche, animals will specialize into something else. It's either that or go extinct. But they are very bird-like animals. Otherwise, they a lot of feathers, a lot of soft tissue on them. I even drawn this one with the big turkey sort of do little throat waddles. We even have nesting evidence for them, and kind of a cool thing with the nest evidence for them is that we have a lot of, especially the embryos from inside the eggs, and of different stages of growth. With that knowledge that we have from very early to late stage, and even just hatching, we know that these dinosaurs were in their eggs a little bit longer than others, and they hatched a little bit more ready to go. It's called being precocial. There are some birds today that are very precocial. If you ever look up megapodes in Australia, they are a type of bird that essentially they're in their eggs for much longer time, but when they hatch, all they have to do is dry off, and they can even basically fly, these birds. And Therizinosaurus, once hatched, would have been relatively self-sufficient itself. There's very little evidence of parental care in these dinosaurs. Again, it's that sea turtle strategy of lay the eggs, maybe guard the nest for a little bit. Once they hatch, they're good. They're on their own. And the other thing we think about them is they're very similar to another extinct animal from the Paleozoic, much later. And that would be the giant ground sloths of the Americas. These large herbivores use these long clawed arms probably to reach up and grab tree branches for browsing, pulling their food a little bit closer to them. And by having this long, large, tall body, that would have been able to give them a good way to reach their arm up rather than that more horizontal posture in other theropods. So they're a great example of not just convergent evolution with a much later mammal, where two unrelated animals, often in different times and places in Earth's history and geography, wind up doing very similar things by being in similar environments and habitats. They're also a great example of divergent evolution, in that they diverged from other theropod dinosaurs, having this radically different body plan. Another good example of divergent evolution would be marine and non-marine iguanas. Marine iguanas have some specialized anatomy for swimming. They have good ways to excrete salt. It's with this weird kind of sneeze you'll see them do sometimes. Whereas the terrestrial living iguanas, they do not have the more flute tail, the more webbed feet. They don't have that means of excreting salt, but they do have better claws and hands for climbing trees. They're a little bit slimmer and lighter. Another thing I want to talk about with these guys, their body shape. A lot of times people look at herbivorous animals and wonder why they're so round and kind of chunky, big fat animals. And one of the reasons they need those large proportional bodies, actual kind of bellies, is they got to fit a longer digestive tract often in there. These animals we know would have probably been doing gut fermentation, where you let something sit in there a long time. You can get a lot of digestion out of it. These dinosaurs also would have been swallowing gastroliths, like sauropods, so those stones that can help grind up the food. And the other question I've heard about these is, why weren't these more common? One of the hypotheses around that is they simply evolved later in the Cretaceous and did not have time to disperse on a wider range. Again, they were only around for approximately, as a family of dinosaurs, maybe 30 million years, which sounds like a very long time, but when you account for the fact that they're individual species among this family, it's not a long time to disperse across the entire planet compared to other dinosaurs who had been around longer. They're a very odd creature, and they were only really publicly known in the past 20 or 30 years. Scientists have known about these for a little bit longer, but really didn't understand them all too well until some more recent findings, especially those nests from China with Erlikosaurus and Segnosaurus, where the young were actually fossilized in egg at different stages. And it's one of those things where every now and then we discover dinosaurs that are just weird. We tend to pigeonhole these animals into certain looks and body plans where we're like, okay, that's what a dinosaur is. And then we'll find something like this. which looks like a big turkey sloth thing. It there's not a lot of animals today that look like this. Like we were talking about with some of the other animals we've talked about. Sometimes we don't have a good modern frame of reference for these animals because the niches they filled exactly aren't around anymore. So you don't have animals that look like them. But it's always really interesting to see. There's nothing with these like big arms. Like a lot of theropods in the Cretaceous tended for smaller arms. Like with the abelisaurs we looked at a few weeks ago, had incredibly small arms. They weren't used for all that much of anything, whereas Therizinosaurs could use these for helping with feeding, defending itself. The big arms probably were feathered as well and probably were used for mating displays. And just like, there's nothing really that can prepare you for finding a fossil like this. They're an animal that the more we learn about them, the weirder they seem to get, which I always love stuff like that. Yeah, it's like it was a really fun time drawing this one, quite honestly, because it's such an odd animal. I went through like 6 different poses I was gonna put this in. And honestly, looking up Therizinosaurus paleo art is a great time because you'll see people, given that we now know a lot about their anatomy, drawing them in very lifelike poses, very true to modern day animals, how they would sit and stand. Being a browsing herbivore, like we talked about, that's an animal that spends probably a lot of time sitting or standing near a tree, sort of just working away at it. I've often heard these compared to giraffes, given just the sheer height of them. They weren't exactly super extreme like some sauropods, but they were still reaching very tall parts of the tree. That's a fascinating animal, and it's one I hope that we get more discoveries on, because I would love to come back to this one at some point with new information. Chuck, you have any questions you want to ask, or anything you want to add about this animal?
Well, you were talking about divergent evolution.
Yeah.
And you said one example would be iguanas on Galapagos. As compared to other iguanas, they're different. They have different functions for excreting salts in their systems. They have a flattened tail so they can swim with it better. Can you think of any other examples?
For divergent evolution, another pretty good one, actually, I just thought of it. It's pandas and other bears.
That's true.
Because divergent evolution is when animals with a common ancestor evolve into very different forms. Pandas are very different from other bears in that, first of all, they have that beautifully striking black and white coat pattern, which doesn't really blend in anywhere. But also their diet is radically different than other bears. They're pretty much almost entirely herbivorous. Entirely plant eating.
And low nutrient, very low nutrient. They have to eat lots and lots and keep eating, so they're dependent on a very friendly climate that grows a lot of food because they have to eat a lot to get the nutrients they need.
And they have to shift what they eat throughout the year because certain bamboo only possess. Which, you mentioned eating a lot, that's another animal that switched from an omnivorous to carnivorous lifestyle to a herbivorous one. It's actually very similar to this animal, where this animal probably spent the bulk of its time eating, which is something we don't often think of herbivores. It's like, they spend like 70% of their time eating. It's a huge time investment because, as we talked about with sauropods, plant material is tougher to get the nutrients out of. You gotta feed a lot of it in there to get the same amount.
I just thought of another example of divergent evolution.
Yeah.
There's a species of moth that is native to the British Isles, and its coloration is very well adapted to camouflage. It camouflages on tree bark very well. Yeah. But in areas where there's been a lot of coal mining and a lot of coal dust in the area, and the coal dust has changed the background colors, that particular moth has developed generations and generations of gradually getting darker and darker and darker to camouflage itself with the darkened background.
Yeah, which is a great example of something that's very early stage divergent evolution. Those very easily could become two different species given enough time. It's very interesting. We often, I think convergent evolution gets talked about just a slight bit more, just because I think sometimes it's fun to talk about the fact that like these certain body plans seem to recur, so sharks have a very long, streamlined body plan, and so do dolphins, and so did ichthyosaurs, a reptile from the Mesozoic. They all have this long, streamlined body plan that's relatively, similar.
Now that you mentioned dolphins, the dolphins we're all familiar with, bottlenose dolphins and so forth. But now there's also a species of river dolphin that lives in the Amazon basin, and would that be divergent evolution from something that actually began in the sea and moved its way upstream?
Yes, so that's actually the river dolphins are actually a great case of both. So there's a case of divergent evolution from marine dolphins. But a cool thing that scientists discovered about river dolphins, there are river dolphins also in India and China. So there's approximately, I think, 2 to 3 living species. We're not sure. We haven't seen the ones in the Yangtze River for a few years. But they are actually not all that closely related. It used to be thought that these river dolphins were closely related, but with genetic examination, they're not. So the multiple river dolphin species are a great example of convergent evolution, while simultaneously being a great example of divergent evolution.
Good one.
We got both in there.
Okay, one more. Are you familiar with secretary birds?
Yes, those are one of my favorite birds.
Okay, but now, they look like a raptor. They've got a head that's almost like an eagle. They got a hooked beak and so forth, but they're members of the stork family. They're members of long-legged wading bird kind of family.
Yeah.
But they're adapted more to hunting than they are to terrestrial hunting than they are to land. So I wonder if that would be an example.
I think that's definitely a divergent evolution from the rest of the stork family.
Yeah.
I think there's also a bird in South America very similar to them, like a Soriema or something. I love a lot of these divergent and convergent examples. We actually got both in there.
Yeah.
It's a really fun thing. When we get into more of these principles, it's always fun to look at the modern examples. Like, I always like to find a modern animal that's somewhat similar and it has something that we can, liken it to, because it helps people grasp the concepts better, I think. And when you're looking at prehistoric animals, being able to find something similar, I think, makes it feel a little bit more real, especially among paleontology, which is admittedly a heavily, speculative field in some cases, where we're lucky that we know Therizinosaurs from some pretty complete specimens. I think just in the 90s they found a dinosaur named Nocronicus in North America, a North American Therizinosaur that was relatively complete. Oftentimes these prehistoric animals, like we talked about with, I think with one of the Abelisaurs, they're known from some of them are known from pretty sparse fossils. We know some prehistoric animal species from single skulls or vertebrae and arm bones. There's another dinosaur, Dinocyrus, which has another one of those with big arms and claws that's not related to Therizinosaurs too closely, but for decades, the only bones we've had of this animal were these 2 massive arms with these claws. You didn't know what the rest of the thing looked like. And it's just something where in paleontology we often do have to fill in the blanks. Which is why oftentimes for most the depictions of dinosaurs change. We talked about the case of Spinosaurus, why that dinosaur used to be drawn radically differently than it is today. And that's because we've discovered more fossils of it. And that's what I like about paleontology and science in general, is as we learn more, we're able to amend our previous misconceptions, we're able to get a little bit of a clearer picture of it. Not just in paleontology, but also in modern biology, geology, chemistry, physics, astronomy. It's all sorts of stuff. It's just we can always get a clear picture of things. And the more we learn, oftentimes, not the more normal things get, but the weirder things get. As evidenced by giant sloth turkey thing. Again, nothing like you hit it up the nail on the head earlier when you mentioned like Turkeyosaurus. It's like, yeah, someone messed up naming these things. I can't believe no one thought Turkeyosaurus. Like future paleontologists, please, more goofy names. We need those. Thank you for tuning in.